of introduction. So, since it's the evening, and I think it is almost a month or so, it has been raining in Delhi, right? Not only in Delhi, the entire Rajasthan and all. So, the much talked topic in agriculture these days is climate change, global warming. So, before and what are its implications in agriculture? So, am I audible? Should I keep this space? It's okay for everyone, I guess?
Sure, ma'am.
Thank you. Thank you so much. So, we were talking about climate change. And there are so many projects, there are so many funding, there are so many COP uh, meetings. You all know that is it really a worth topic which we all should be worried about? Okay, so one thing is the prediction of climate. It is a very difficult thing, right? See, the most common prediction is prediction of say rain or maybe prediction of, so it depends upon so many factors. Maybe maximum temperature, minimum temperature, how much is the relative humidity, wind velocity, and so many things. So that decides whether the rain, there are projections, short term, long term, medium term projections of rain. So it's a very common phenomenon, right? Monsoon comes every year. Still, the prediction says there might be rain. So rain might occur, rain might not occur as well. So my point is when the prediction of such definite phenomena, such common phenomena is very difficult. How come the prediction of uncommon phenomena like climate change is really a practical thing? So the terms like prediction, projection, a lot of science is involved in it. And that too predicting the change in the climate, maybe in the temperature or CO2 levels after for 100 years or maybe for next century and so is very difficult. Why I'm making everybody conscious about using this term is it's a very specific term. I'm saying it has been raining from last 20-25 days in Delhi, and not only in Delhi, in Rajasthan, in Western Rajasthan as well. So does it make a climate change? So we should be able to understand what is the difference between weather and climate. That is the first thing. Then we should be able to differentiate how much it is going to impact on our agriculture. Agriculture, we every second person is talking about climate change. Not only we are worried about the increased temperature and higher CO2, we are more affected by through climate change about road productivity. So before we come to the agronomic interventions, climate resilient agriculture, what all are the practices which we should follow? We talk about conservation agriculture and so many things. But before that, we should focus what exactly this climate change, right? So you see this beautiful map. I think this is the most beautiful country in the world, and you see the variations in the climate. You see, we have a place like Dras where the December night temperature is minus 45 degrees centigrade. And in the same country, we have a place like Chennai and Thiruvananthapuram where the night temperature is 20 degrees centigrade in December night. Okay? You see, we have 52-degree temperature in June in the western part of the country, and in Tawang we have 19 degrees centigrade. Such a variation is there. Then in Thar Desert, the diurnal change is around 30 degree. So the difference between day and night temperature is 30 degree. And at the same time, in Kerala we have 8 degrees centigrade also. We have a place like Jaisalmer where this year we have good rainfall, but the average rainfall remains 9 centimeter. And we have Masimram on these places where they are more than 1000 centimeter of rainfall. So should as a country we should be worried or we should be so tensed about climate change? Maybe one part of a country is affected by one climate aberration, but at the same time the other part of the country will be getting the benefit. So it is not the climate change which is very dangerous. We should be alert of it, but we should be able to tap the opportunities in the disguise, right? So we can tap if there is increase in temperature. There is a increase in temperature. Maybe our apple orchards would shift, but at the same time we'll have larger area under wheat cultivation and the mustard cultivation also. So the climate change, it is not a matter of a day or two or a matter of a country or one country or two or maybe a group of people. Some phenomena are by the nature, some phenomena are anthropogenic or which are created by human beings. But when we are facing such things, instead of being very pessimistic about it, we should look for the control, and at the same time we should look for the opportunities also which we are existing in the climate change. Now this as a simple graph, there is a blue line which shows the increase in the CO2 concentration. and the black one shows the increase in the ambient temperature, and it is the average of almost 600 of millions of years ago. These dinosaurs, they have survived for more than 200 million years ago, and we have human being have been existing in the world only from last 2 million years. So we are a very small and a very recent and new partners into what has been happened in the earth over the past. So in the past also, our earth, our planet has been continuously subjected to increase and decrease in the CO2 concentration. And the theory says how the life has evolved on this planet is initially the temperature of the earth was very, very high, and it was because of the huge volcanic eruptions. So these volcanic eruptions used to emit a lot of CO2, and there was no substrate which could tap that CO2, and out of that response, life originated on Earth. And why life originated first in waters? Probably because we have a three-fourth of large of area, almost 70% of the Earth's surface, which is covered with water. So that has a more opportunity to trap that free CO2 in the form of sequestration, in the form of photosynthesis. So that is how life originated. So my point is we have been subjected to increase and decrease in the temperature in the past as well. We will continuously be subjected to that. And there are two schools of thought. One we are saying is global warming. The other school of thought is there. The other thought of the people says that we are very soon we are going to face the global cooling as well. So these are some of the natural phenomena. Earth has been subjected earlier also, but now we are a larger population and we are shrinking towards the limited resources, and we have been very exhaustively using our resources. That is why we talk more about climate change, especially in the agriculture. So this is the evolution of the Earth. Now there are, as we were talking about perceptions, perceptions and predictions. So some perceptions, some words see looks very negative for us. If somebody says greenhouse effect, so the immediate response is there must be something negative. This is the overall distribution of the Earth's the radiation which are coming from sun and which are received in the earth on the earth, and what is its diet. So how much we are receiving, some of it is trapped into the atmosphere only. It comes in the form of short waves. It is and then it is re-radiated back into the atmosphere in the form of long wave. Okay. So there are different traps of these greenhouse gases. Some is taken by the atmospheric water vapor and so on. So if you see the balance, it's such a wonderful balance so far. But in the last maybe 5 to 7 decades, or maybe in a century or so, that balance has been disturbed. That balance has been disturbed, and the nature has the capacity to rebound. But when that balance loses its elasticity, it goes beyond a certain point where it will be difficult to come back. Then it becomes a difficulty. So what this greenhouse effect is? It is nothing. It is simply, it doesn't say you wear a jacket or a coat or a blanket during winter. So a jacket or a coat or a blanket doesn't have a heat of its own. It simply prevents the heat which is emitted by body to escape, and it traps that heat, and that keeps you warm. And similar is the greenhouse effect. We have a neighboring planet which is Mars. You can see the average temperature is minus 55 degrees centigrade because it has a very weak greenhouse effect, and the surface is much colder than that of the Earth. Another neighboring planet is Venus, which has a very high or very thick, intense greenhouse effect, and the temperature is 462 degrees and centigrade. So both our neighboring planets have the extremes of greenhouse effects, and the life is not possible there. It is only the nature, or it is only the beauty of this planet that it sustains life. And so greenhouse effect is not a culprit, it is not something negative. The point is the perfect greenhouse is there which exists on the earth, which helps in balancing the life and which sustain the life. So without greenhouse effect, it would not have been possible for us to survive on this planet. It is because of this only that we are surviving there. So we have talked about different natural disasters. It could be earthquake, it could be tsunami, it could be volcanoes, hurricanes, so many things are there. But now the major natural disaster is climate change, because we see all these phenomena have become secondary, and they are also one of the reason because of the climate change. So there are different definitions. So if there are some students, probably we will be you before attempting any question, you should give some standard definitions from a standard authority like FAO or maybe WHO or UNFCCC or so. So these are the bodies which have a specific. So we have to look for what exactly this climate change is, and it covers 2 points. It is a statistical distribution of weather change patterns, and they should exist from decades to millions of years. So if there is a sudden flood in the Barmar district of Rajasthan, that doesn't mean it is a climate change. It has to be consistent over the years, and that becomes then that become the integral part of that place. Then only it can be called as a natural. Otherwise, we call it weather aberrations. Okay, so one has to be wise in choosing the two words. And people are very enthusiastic about using the word climate change, but being the science students or maybe the science practitioners, we have to be very very cautious in choosing the terms, right? So as I said, that it is not a new phenomena, and climate change has been happened in the past as well. Our earth, suppose it is tilted maybe at a 23.3 degrees centigrade or so, that is a pure geographical thing. So just imagine if that tilting is that changes from point is 0.3 degrees centigrade, 23.3 to maybe it becomes 23.4 degrees centigrade. What it is going to cause the change. So since we are involved, many of us are involved in agricultural sector. So when we talk about change, so the change which is brought by nature is very very huge, very very drastic, and it is very impactful. You can see, like, there will be a sudden, there will be high humidity, very high temperature, and suddenly there will be a cloud cover and a rain. So keeping the room at 27 degrees centigrade or maybe 25 degrees centigrade through AC exhausts a lot of energy. Can you imagine the force of nature? We take soil samples and bring them to for in the lab for analysis. So bringing half a kg sample of maybe 36 or 48 plots, it takes 3 labors the whole day. Can you imagine the force of nature which has drifted the continents apart? So what I'm saying is, if there is a slight change in sun's output ratio, solar radiation, we all know fission and fusion activities which are taking place, reactions taking place in the heat output of sun. If there is a minute change in that, it is going to cause a huge change in nature. Earth's orbit, it has a specific orbit. What if it deviates slightly in the orbit? We all know why Pluto is no more considered as a planet, because it doesn't have a definite orbit. All other planets have a definite orbit, but what if it changes slightly? Then it causes the changes in the season. You can imagine a place in Delhi or in Agra or P probably where the same earth, the night and day temperature or the summer and winter temperature, there is a huge difference. Then we have different continents. So all these factors, they also contribute to long-term climate change. But what we cannot do anything about these natural factors, but there are some human activities also which are involved in the climate change. All burning of fossil fuels, cement manufacturing, refrigerants, industries, landfills, agriculture. One should be concerned about, we will be discussing in the coming slides. So these are the 10 indicators of warming world. They say there are 10 indicators like melting glaciers, snow cover, increasing sea level. So you since we are sure of these 10 indicators, then with confirmation we can say that, well, yes, there has been a climate change, and climate change is truth and evident in the today's world. So apart from that, we are responsible for all these factors where human induced or anthropogenic sources of climate change are there. So as I said, climate change is not a new thing. We have been subjected to continuously change or increase in the CO2. But you see, from 1860 to maybe the present time, then you will see that the blue curve, so there is a pink line and there is a green line. So the pink line is the average of last 100 years, and the green line is the average of last 50 years. You can see the angle or the slanting. So the sharp, this is known as hockey stick syndrome. Like, you know how the hockey stick is placed. So this says that the pace of change has been very very fast. If the pace of change is slow, there are other balancing factors in the nature which could have combat this climate change effect. But since the change has been very fast, the other subsidiary activities which are in response of this climate change are not stable or are not powerful enough to combat that. And that is why we are talking more about the signs and signals of climate change. So again, the point is, there are some indicators which says that climate change is there, but yet you have to be very particular in making whether it is a reality or an exaggeration. We all know this gentleman. He has worked a lot, and he was the chairman of UNFCCC when a statement was given that with the given projections, maybe by 2035 or so, in the Himalayan glaciers would totally disappear. And that statement was given not elsewhere else, but in the Sunday Telegraph of United Nations, and that was a big debate or a hot debate, and out of that, probably it was difficult for him to answer that, and probably he had to resign from this post also. So just giving the jargons like, say, if it is zero point 0.8 to let us be zero point 0.9. So these are some of the projections. Like World Bank says there has been no significant change in the climate, in the temperature. Government of India data says that it's zero point 0.4 degree, and UPC and IPCC says that it's 0.6 degree or so. So one has to be cautious, very cautious in choosing these words. So these are also some of the projections. You can say the green and red. So how it has been, how the trend has been for different planets. So by 2029, these are the data and statistics, and it is going to be very, very hot by the end of this century. So the projection says that we have to start, and these are some scenarios which are given by. So what the future projection says, the major is about precipitation. So like in climate phenomena, there is nothing in isolation. So temperature, CO2, precipitation, wind velocity, deforestation, they are all linked and connected. So this graph shows that over the years, maybe the total precipitation remains same, but the distribution is going to be affected. We need more number of rainy days in agriculture, but we will have more in the form of downpour. हम बादल फटना बोलते हैं ना. So there will be a huge downpour. We have seen calamities. We have seen this year also. There have been huge floods from Jammu to Punjab and everywhere. So, and because of that, the Agriculture Research Services ARS prelim exam has also been postponed because students had given. So these type of phenomena will be very frequent in the coming time. And there is also one more thing that we say that wetter areas will become more wet and dry areas will become more dry. Why do they say that? Because if you increase the ambient temperature by 1 degree centigrade, the moisture holding capacity increases by um, 5, 5, 5% of so when the drier areas, they have the substrate is very less, and even then because of the high temperature there will be evaporation, but that is not enough to cause it into the form of precipitation. So that is why the drier areas will become more drier, and wetter areas, the substrate is huge and the water cycle is going to be very, very fast. Okay. So in that cases, wetter areas will become more wetter. We need more number of rainy days. The definition of rainy days is more than 2.5 centimeter rainfall per day. So the distribution is important. Total amount of rain is not important. If there are three downpours, that will be enough disastrous for the crops to vanish. So these are says that these are different scenarios which are proposed by IPCC. Scenario one is it is going to be business as usual. Scenario two is only developing nations will be working on it. Scenario three is both developing and developed nations will working in this area, and so on. So there are different projections. What they say are very heavy rainfall events are going to be increased. Heavy and very heavy are going to be increased. Light and moderate rainfall, which are good for your groundwater recharge also, and all these factors. It causes less of soil erosion. It causes less erosion of soil fertility. So these wanted phenomena will be less, and heavy and very heavy events will be high. And this is the frequency that how we are going to, or maybe how our extreme weather events are going to be happen, including cyclones and so on. So we have to be more prepared for it. And this is about the precipitation distribution. And as it is evident from this, you can see the comparison between 79 to 2003. There has been melting in the glaciers, and there is increase in the this. So as a consequence, sea level will increase. And after the tsunami, we have visited the Andaman Islands, and there are some fields which are still inundated with that saline water, and that has affected the primary productivity both for agriculture and fisheries. And coastal areas, the decline has been huge, soil quality reduction has been huge. So these are the consequences. And you know that when there is increase in temperature and increase in CO2 concentration, there will be high carbonic acid which is released. So that is a weak acid although, but it erases the color, or it reduces the, or it fades the color of the natural colors of the coral. So marine life is also affected. Due to higher temperature, there is a huge algal bloom, and that prevents the penetration of light to the deeper layers, and that has also affected the marine life. As I already discussed, that algal bloom is responsible because of this is also known as CO2 fertilization. Means if there is high CO2 concentration, higher and these algal blooms will be there. And we have also there are also projections that within maybe coming 100 years or so, there will be no island like Maldives if the situation remains as such. About ozone also, we have seen the sharp depletion, and you can see it till 1984 or so. But after 1979, there was a Montreal Protocol, and that usually that inhibited the effect of the use of CFCs, and after that we are using hydrofluorocarbons, and there are reports that some of our ozone layer has been repaired. So ozone also, if it is in the stratosphere, it I have shown it here. If it is in the stratosphere, it works as a deterrent for UV lights. But if it is in troposphere, it also acts as a major air pollutant, and it causes very high damage. So as I was discussing that after the Montreal Protocol, there has been increase in the hydrofluorocarbons, and they are responsible for the. So if you see what all are the solution and why do we discuss it in agriculture? So the the picture which has been shown here is the executive secretary of UNFCCC, and she says the life depends on biodiversity. And the major threat for climate change is biodiversity, and they both are interlinked. You cannot expect a high biodiversity under a high climate change scenario. There has to be there has to be immediately check in the losing of biodiversity if you want to stabilize. So you can see the number of existing species. We have, as I said, we have been living only for 2 million years, and before that, eukaryotes, prokaryotes, they have been living for 4 billions of years. So there has been, as I was saying, that there has been continuously subjected to high and low temperature. There has been a continuous decline in the living species also. You know about red data book, extincted species, endangered and all. So this earth has been already subjected to 5 mass extinction. Mass extinction means there will be sudden climate change, maybe sudden climate phenomena, and due to which a huge number of species will suddenly decline. Okay, so we have already been subjected to five, and we are going for the sixth mass extinction. Maybe probably after a few centuries, there will be almost 40% of the species of the existing species will become extinct. The problem is not that it has been it has been happened in the past. The pace of this change is very, very fast, and by a factor of 1000. So the pace which we have experienced in last five, the present pace is 1000 times of it. And it is about the human health also. You know, I always give the example of mosquitoes. They used to be only in 2 months of 1 year. Once there is a shift from winters to summers, and another there when there is a shift from summers to winters. Apart from that, there used to be no mosquitoes. But nowadays, we have to put mosquito repellent throughout the year, day and night. And still, like I understand that around 2015 or so, there was dengue was a huge havoc in Delhi, and people have lost their lives. So R&D takes its own time, but nowadays dengue has been not that serious problem. Although we have been very alert and careful also in reducing the mosquito infestation, but yet R&D takes its own time to take medicines, to take treatments. We all have witnessed it in Corona because it was all testing, and some people blame the R&D also that the vaccines are responsible for sudden heart attacks or maybe some other failures in the this body or human system. So R&D takes its time. We need vaccines for different things, for different problems, but it may take time, and by that time there will be a huge loss. So this is a global exposure. The countries, almost the entire world has been subjected to it, except those very, very extreme countries which are otherwise most of them are. So if now, who is responsible? Where should we work? Before that, we should set the accountability. You compare 1970 and 210. We have compared it with our similar developing nation like China, Brazil, and a developed nation like US. So per capita consumption is still very, very high in a country like US. And India, we are the minimum among the four countries. But they have a very, very strong argument. But see the population. So per capita, although is less, but the population of India is so high, right? So the total becomes very, very high when you take the total population. Even though per capita, but when you count it to the 140 crore people, the amount becomes very, very huge. So they penalize it. Why do we need to know it? In international market, you all understand after the coming of GATT and after the WTO, after GATT, we all are signatory of it. And we have to stand somewhere and do negotiations in the open market. Now the whole world is one. It's not that we can stay in isolation. Okay, so and this is, you see, the energy consumption. We have been exhausting our oil. We have not tapped the nuclear and renewable energy so far. So if that continues to happen, if we are going to continuously exhausting our fossil fuel resources, then suddenly there will be an imbalance. Now greenhouse gas emission, if you see country wise, China is a major culprit. Then maybe on this slide shows the other are responsible. 15% is America, and so many. So we have to see our contribution. There are some global impact. We have seen that reduction in terrestrial and Arctic snow cover, rise in sea level, decline in crop yields, high frequency, and these, and ultimately which leads to biodiversity. Now, what are the impacts for agriculture? Temperature is going to be short. In short-term change, there will be enhanced enzyme activity, gene expression, carbon assimilation. So, and then the soils will, as I said, that there will be more pressure in agriculture. Right now, also, we are using more than 85% of our natural water as agriculture, apart from other industrial and domestic and uses. So, when these soils become dry, it's going to be very, very difficult. So, water demand will be more, there will be reduced supply. Pest, I said that under high temperature, high humidity, and uncertainties, the pests, especially the insect class, which are the major enemies of agriculture, are going to be severely, because that has a zenith of evolution. 85% of the existing species belongs to class insecta. So they are very hardy, they are very adaptive. So these will remain the major challenges. Production, of course, when such certain constraints will remain, then the productivity will be less. For livestock also, we have lost our indigenous breeds. They were resistant to the heat. Now we have shifted to HF. Most of the cattle farm, they have HF, and they are not able to tolerate that because they don't have hump. They don't have that inherent capacity to increase to tolerate that high temperature. So most in many of the milk dairies, you must have seen that there will be coolers and ACs even for the cattle, and their production is as high as 60 to 65 liters per day. But as the temperature increases, they are the first to collapse, and it will be so. Fishery also, as I said, that there will be high abundance and high spawning, but the productivity is going to be less because of the algal bloom and the competition within. And if all this happens, then suddenly there will be economic losses. Okay. There are some positive effect, maybe as I discussed in the climate, on this low or in the temperate conditions where the temperature is very, very low, and the crop duration exceeds maybe for 4 months, more than 4 months. It goes up to 5 and 6 months also. So there the duration will be less because they will get more growing degree days and higher sunshine hours for the crop to complete its cycle. So as I've been discussing since very beginning, that how agriculture is affected by climate change, and why we should be answering to some of the questions, and why agriculture should be taken, because we are both a creator and also a sufferer. How we are creator? Two major factors. Like one is fertilizers, GHG emission through rice cultivation, enteric fermentation because from the cattle, because we are also responsible for that, and then how we are suffering. So this, you can see, major gas which is responsible for this global warming, or which is considered as greenhouse effect, is carbon dioxide. So in carbon dioxide, we are in agriculture, we are using huge farm machinery. We are burning fossil fuels. So that is responsible for emission of CO2. How methane? There are two reasons. One is enteric fermentation, because we have the largest population of cattle in the world. Although the productivity and lactation is less, but we are emitting huge. And another is rice fields, where the methane emission is a major problem, and we are, most of our area is under puddle transplanted condition or under low lying, where CO2, this methane emission is major. Nitrous oxide, it is a bit disappointing that we have not not increase our nitrogen use efficiency beyond 40%, 40 to 45% under best conditions. So if you are putting 100 kg of urea, 65 of it is going as waste. So we have to be accountable for that also, and maybe some few other reasons. So these are the major GHG contributing gases: carbon dioxide, chlorofluorocarbons, very less. Agriculture is not directly responsible, but we use it for refrigerants. Then methane, these are the responsible. So if you see the overall sector, so agriculture directly is responsible for 13.5% emission. But if you include forestry in it, because that also is a part of agriculture, then together they makes around 30% of the total GHG emission. So we are continuously, fingers are being raised on us to increase the efficiency. And if you see the major contribution, enteric fermentation, as I was discussing, we have the largest population of livestock, and the ruminants, they have that type of system in their stomach that they do enteric fermentation, and after that methane emission is there. Then the cow dung of the animal is also is the greatest waste, है ना? So there is a huge emission of methanes from there also. And also when we talk about crop residue burning is not responsible for more than 3% of the climate change. But the people who are living close to the Delhi NCR, that region, they are where the farmers, they penalize farmers the most. There is a satellite modus, it traps even a small fire in the farm areas, and those farmers are penalized both in Haryana and Rajasthan. But apart from that, all these rice cultivation, manure management, then cultivation in organic soils, burning of crop residues is very, very small. Other factors are there. The GHG emission is small. So one interesting fact is, if you see the global warming potential, it is assessed or calculated on the basis of carbon dioxide. So if keeping 1 unit for carbon dioxide, you see methane is 21 times. Then nitrous oxide is 310 times. Hydrofluorocarbons, and they are all very, very high. So even with their very high potential, luckily their lifetime is very, very less. You might have a question in your mind that why water vapor is not considered as GHG, although it is responsible for global warming. Because the stability of water vapor is very, very less. To assess the global warming potential, the particular gas has some stability or maybe some life to come with. Okay. Now these are some of the graphs which says that which gas is responsible for which, and then how the trend has been so far. Okay. So India ranks, if you see in the freshwater withdrawal, we are number one. Irrigated land area, we are two. The PM or the particulate matter concentration, we are 84. Hmm. And these are some of the. So this is just a slide to discuss why PM 2.5 and PM 10 is the most discussed when we talk about pollution, as we were discussing about the crop residue burning. So this section, you can say the gray color, it is the section of your hair. Huh? So how thin our hair is, and this is its section. The particulate matter 10 is blue, and similarly we go for 2.5. So which among the two is more dangerous, and why do we discuss air pollution in these two terms? Once it is PM10 and above, it is going to our lungs, and they are not filtered in our lungs. So where the particulate matter 10 is more, people will suffer from respiratory syndromes. But when it is 2.5, it is able to escape our lungs through our alveoli and trachea, and then they goes to the blood system also. So then there they are more harmful, and there are more problems of cardiac arrest and these problems. Okay. So when we talk about the GHG emissions, more than 42 countries are responsible for more than 50% of the total emission, while 89 countries have less than 30 or maybe 20 or so. So when we talk about emissions, you can see in India, the red spots are there, and they are the cases of danger where high fertilizer consumption is there, and less efficiency is also there. And this is the for the subsector livestock. So see, maximum dots are there in our country because we are the largest country for livestock. And then we talk about rice. There also we are towards the higher emission, which needs to be addressed. Then you must have heard about the long queues of farmers waiting for DAP, for urea, and a lot of subsidies. So the point is whether it is a feast or a famine. Why we call it a feast? Because our efficiency is 30. You are putting, if you have to get 30 kg of nitrogen for plants, you have to put 100 kg of urea. It's a very exhaustive process through which urea is formed. Okay, in with Haber's process, we first synthesize ammonia, then it is synthesized in so many. So whether we have to see the green color shows the excess of nitrogen, and we had a project on from NASF, and we assessed for a whole IGP, transgenetic, middle, upper, and lower genetic. What is the scenario when we see 75% of the areas are overfed by nitrogen and underfed by for P and K? So that aberration has caused it like this. Okay, so and this is the use efficiency. We are hardly 30% or so. In Africa it is even more than 100%. Means they are not putting and they are exhausting from the available resources. Now again, if we compare ourselves with our similar developing nation and a developed nation, you see right from 1970s where we started our green revolution, we started using input intensive agriculture, we started using fertilizer, we started using herbicides, high yielding varieties, and so by the time US has already tapered its fertilizer consumption. So it is not that they are not utilizing or they are not putting more, but they have become more efficient. Instead of 30, maybe they have reached up to 70, 75% or even 80%. Our country, neighboring country, China, it has also tapered, and India is still on rise of the fertilizer consumption. We have started with less also. Present consumption is around 140 kg per hectare of all the fertilizers, which is very less as compared to China. But China has stopped it, has tapered it, but we are still on the rise, and I don't know how far we are going because our input responsive ratio or fertilizer response ratio has also been declining. So what are the trends in GHG? It's a very interesting graph. You see emission from Indian agriculture has continuously on rise. Why? But the relative to India's contribution to GHG, we are declining. How we are declining? You see the second graph. Emission per hectare is increasing because our fertilizer consumption is being more. But if you see the food grain production also, we started from 50 million tons and now we are around 350 million tons. So we have increased our food grain production also, and these are the points where we defend our country, right? We say that we are, although we are emitting more, but we are producing more. So per unit of production, we are on decrease, and this is how we defend on our international markets. Otherwise, if you see the efficiency is 30%, emission of methane is very high, what is going to happen? Hmm. We have an area around 47 million hectares for rice, and if you calculate it, it is going to be huge. So this is how we defend ourselves, our country, and our rice cultivation. So probably, since we are saying maybe we have impositions like Punjab government has said that 15th June से पहले transplanting नहीं करना because it is going to get to put more and more pressure on your groundwater. So avoiding that, we should wait for natural rains and then only transplanting is permitted. Okay. So this fertilizer consumption is continuously on rise, but we are decreasing. So if this is the scenario of the whole world, which country is more vulnerable for climate change? And we are very vulnerable because most of our economy is dependent on agriculture. 45% people still dependent on agriculture and allied sectors. So we need to be focusing more. So what are its impact on crops? See, if we talk about climate change, there are two things, majorly two things, right? One is increase in CO2 and another is increase in temperature. Until unless it is only increase in CO2, this is known as CO2 fertilization. It is very, very important for crops. Both C3 and C4 crops have huge potential and they can tolerate up to 500 ppm CO2 also, not an issue. But when it is accompanied by high temperature, then it causes a huge loss because your grain filling period will be less, your terminal heat will be less, your initial heat will be less. There will be sudden increase in the physiological activities, the response of the plants, and so on. So that is going to be very, very harmful. So we have to, the major out of the two is also increase in temperature. Okay. So what do plants need? They need light, they need CO2 and oxygen, they need water, temperature, nutrients, and micronutrients. And you can see the top four, they are affected by the climate change. So then that is why we say we should study about agriculture. Now these are the response of different C3, and C4 plants and how they have been doing it for the nutrients and in the changing scenario. So this is just a brief. This is about the overall land use systems and agri-food systems. Okay. So what happens with climate change? Not water is limited, when water is limited, and what when there is increased CO2. So we have trials going on. What if there is only CO2 increase? What is if there is temperature increase, what is there, both are there, and what if the rain distribution. So different set of treatments and different set of information give you different. So these are under how agriculture, this is the response of C3 and C4, right? You can see the CO2 compensation point is relatively less for C3 plants. So initially C3 will be responding better, but the C4 will be C3 will be responding better, and that there will be a plateau for C4 very fast as compared to. Yeah? So response for C4 will be more, but this plateauing and stagnation will also be less. So this is the response for maize, wheat, and rice, major three staple foods in where under low altitudes and higher altitudes, the response says that under low altitudes there is a sharp increase as compared to the higher altitudes. Higher altitudes there will be less decline, more decline under lower altitude. So this is the overall projection for 2020, 2050, and 2080. So the reduction was 6%, 23%, and 25% in case of wheat. And for rice, it is 4, 7, and 10%. However, all these losses can be addressed if we go for agronomic intervention. So this is where I'd like your focus on that. What are all the interventions? Like this is a beautiful variety which has been bred at IRI. He was the then Director General, then the breeder, that is Rajveer Yadav sir, and Dr. A.K. Singh, the then Director of IRI. So we have come up with heat tolerant varieties. We expect that, but the limitation with the breeding program is either you can have a variety which is tolerant for initial high temperature or at high temperature. We cannot have the variety which can combat both type of drop that high temperature. Okay? So these are the different scenarios. Now, this is the entire IGP, which is the food grade bowl of the country. And you can see the vulnerability. The darker is the color, the more is the vulnerability. And most contributing parts are the most fragile part, where which are subjected to certain type. And this is the vulnerability assessment of the entire all the districts of the country. They are 730 or maybe 740 or so. So they say that how the different districts of where are vulnerable, are very highly vulnerable, highly medium low, or very less vulnerable. So what can we do now? If we go with the similar situation, we are going to triple our CO2 concentration. And if you act right now and if we stabilize it on that, then maybe we will be avoiding the ducting. And the triangle, the yellow thing you can see is the stabilizing triangle, where we have to we have to keep ourselves somewhere in between this yellow. Okay. So, but stabilization is easy to speak, but it's very, very difficult to achieve. You can see from the today, the origin is today, the first mark is at 100 years and the second mark is at 1000 years. If you start acting today, what will happen? CO2 emission peak from 0 to 100 years. CO2 emissions will stabilize probably after 500 years of today. If you start acting today, then CO2 stabilization from 100 to 300 years, it will take this much. Temperature stabilization will take few centuries. Sea level rise, if you have to stop it, it will take centuries to millennia. And sea level rise due to, if you stop, even if that these many years will take to get that equilibrium. Wow. So that is why it is very, very important that we should act today. Now, two things which we often discuss in climate change is one is mitigation and another is adaptation. Okay, mitigation is you avoid it. You stop using nitrogenous fertilizer, there will be less emission. You are growing rice under puddle condition, you go for direct seeded rice, there is no water and there is no methane. And adaptation is you have to become more efficient. Whatever you are getting, you are producing more out of it, right? These are the two responses. So adaptation, crop has to be more resilient to all the situations, and for mitigation, it has to be more efficient. With less, you are getting more. So our target is both, and this is a wonderful figure just to summarize what agricultural practices we need to do. Right? You can see there is an x-axis which says that there is no mitigation, and then there is a and then there is maximum mitigation. From left to right, there is no adaptation, and then there is very high adaptation. Okay, nobody will choose where there is no adaptation and where there is no mitigation. We will go for some mitigation, but then there is no adaptation. That has its trade-off. Similarly, where adaptation is very high, mitigation that also has its trade-off. So we have to see on the top right corner where there is synergies between mitigation and adaptation. It is not that they are separate. They are overlapping. So some of these strategies, and there we have no regret adaptation, no regret mitigation. Okay, so we have to work on these synergies. It could be nitrification inhibitors, it could be direct seeded rice, it could be laser land leveler, and so on. So there is, as I said, there is no distinction between adaptation and mitigation. These all are the strategies which we have to adopt in making the climate change a success. So how much is the potential? Okay, we are going to do all sacrifices, we are going to make all changes, but what is it worth doing? You can see out of the world and India, we have 75 this units, this million tons of carbon dioxide emission that we have mitigation opportunity. Okay, if you count it for the whole world, it is 150. Okay, so we have huge potential. It is not that our efforts will go waste. We have that much potential through agriculture. Now these are different factors. It is showing, the red one is showing that this much of CO2 mitigation potential is there with cropland. The blue color says nitrous oxide emission potential. The green says methane emission. If you go for rice management, rice fields management, livestock, we have huge potential. Okay, so these are the three major greenhouse gases, and these are different agricultural sectors where we could focus to reduce the uh, and then simple like sowing date, shift in sowing date, selection of variety, irrigation efficiency, fertilizer use, additional input. So if you do all these things, then we have a high potential and high chances that the net vulnerability for all these factors, you can say, it is very very high for additional input, it's for fertilizer. So this is how you make your strategy. So another thing is, we talk about organics, we talk about natural ones, but even if you are following an ideal integrated nutrient management practices where the below ground biomass is subjected to be taken into the ground, and then there is a perfect NPK, then you can see the comparison. The sequestration potential doubles when we add the FIM as with integrated nutrient management along with NPK. And these are the summaries of 26 years long, this 32 years, 8 to 32 years, average is 15 years from 26 different sites, and that is averaged. So that says that when there is control, means no fertilizer, no FIM, no organic, any of the organic source, then the sequestration potential is less. It will be slightly high when you are only on using nitrogen, but again it will be negative. If you are using NPK, then if you are using FIM, then also it is less. But in the last bar where you see both NPK and FIM are judiciously used, there is a huge carbon sequestration potential. These are different methods. We go for 4R, stewardship, right source, right method, and all. So right source says that if you substitute your nitrogenous fertilizers from nitrate to ammonical, then the inhibition is more. These are some of the nitrification inhibitors. And as from the very beginning, I've been discussing more and more on nitrogen because that is the most used fertilizer. These are specific agronomic technologies like application rate should be ideal, timing and placement should be there, enhance fertility, different use potential cultivars, use efficient cultivars, use responsive cultivars. So to reduce this. And these are the climate resilient practices and these are the adaptation approaches. Again, how much potential we have is there that we have discussed, and crop diversification. This is very, very important. Instead of going for single rice field, although we have a devised mechanism of purchase of machines and everything, still some diversification should be there, especially with incorporation of legumes. And it is not that you have to entirely change. The 2 points I want your attention. One is addition of legumes or inclusion of legumes. We have different scopes. Additive series means rice, wheat, and additional crop of moonbeam. Substitute, at least replace either Kharif or Rabi once in a year with a leguminous crop. Break crop. You are doing it rice wheat maybe for 5 years or so. Just give your soil a break and use that. Then intercrop. We have huge areas. And another attention is the northeast area. We have around 12 million hectares of fallow rice. That area should be tapped for cultivation of oilseeds and pulses so that we have additional crop and then we have stability, then we don't have erosions and so on. So this diversification is very, very important. Also from food security point of view. And again, we were talking about Ixona, Madam, who was saying about biodiversity. Such a huge biodiversity we have. Name the pulse, we grow it. Name the spice, we grow it in our country. Name the food, we grow it. Although the productivities are less, and some of the forgotten heroes like millets, they are again in the picture from 2023. In fact, our honorable PM says that it's not a international year of millets. We should celebrate international decade of millets, right? So this is the biodiversity. We need to tap the diversity. We should not lose, and whatever suitable for which place. We have committed a mistake, a huge mistake in introducing rice to non-traditional areas. Similarly, we have committed a huge mistake in eroding or maybe forgetting our village. So go back to basics. The concept. Then we have to work for smart kitty, smart village, where it's not the one thing. We have to be, we have to approach, keep a holistic approach. We have to beat the drums together to get the optimum. So as I discussed, there's nothing to be disappointed. We have some good news as well. We have some positive effects. As I said, that we'll have less frost days in mustard. We'll have some potential in groundnut also. Increase in some, since we have like this year, because we have rains till August, we expected till September also. So the early sowing of chickpea and mustard will give an additional crop in summer and Zayed season. So these are the opportunities which we have to see in the climate changing scenarios. And this is the shifting apple cultivars. This is an opportunity. These are some of the facilities which we are doing at IRI. So I invite all of you, if you could come and visit sometime at IRI to see these facilities. And open top chambers, elevated CO2, as we were discussing. Now, this is my concluding slide. I request everyone to pay attention to it. Developing countries have make their as I was showing the US graph. It has stopped, or it has tapered, or it has in fact stabilized its fertilizer consumption from 1960s or so. So developing countries have become developed countries. Okay? And now developing countries are not satisfied, and now they are converting themselves towards climate smart development. So we are still developing. So if we follow that path, it will take longer. But if you become climate smart development right from the developing countries, you know the what is this theorem? Where the hypotenuse is shorter than the plus of two, Pythagoras theorem. So we should follow that red path. So instead of becoming developing and then to become climate smart, we should become straightway developing to the development. Why? How do we do it? With low carbon, with low nitrogen, and low energy. So it is not that we are making of a less low profit and low interest of stakeholders. We have to become more and more efficient. Just a reminder for all of us: there is no place like home, and there will be never be again. So do your part. There's no other place for us to go. It's our home. We have to save it, and it's a collective responsibility. So 7 billion people together can make a change. And this great gentleman, he says that a society has two choices. One is wait until the catastrophe fails us. We are sitting, not doing anything. We are ready, whether it is tsunami, volcano, or whatever, or we need to act to fail the catastrophe. So with that, I think I have finished in time. I kept deliberately, I finished